During a routine dive off Key West, Florida, a 4-man submersible gets entangled in the wreckage of a sunken warship. They can't free themselves, and rescuers need to get to the men before their life support systems run out. It's the 17th of June 1973, and crew of the Johnson Sea Link are getting ready to make a dive 15 nautical miles off Key West in Florida. They're diving to the wreck of the USS Fred T. Berry to retrieve a fish trap designed to help scientists monitor fish populations. The Berry was a US Navy destroyer commissioned right at the end of World War II. After it finished service in 1971, it was scuttled in this location off Key West to create an artificial reef for marine wildlife. One of the men on board the research ship, Robert Meek, is an ichthyologist or fish biologist. He's studying the fish who inhabit the wreck of the Berry. The Johnson Sea Link is a specialist deep-sea scientific research submersible. It's licensed to take people and research equipment to a maximum depth of 305 meters. It was built 2 years earlier and is designed to carry up to 5 crew. The crew are split between 2 separate compartments. The pilot's compartment is an acrylic sphere 1.5 meters in diameter and approximately 10 centimeters thick, which gives a panoramic view during the dive. During the dive, the pilot's compartment stays at the same air pressure as the surface. The rear compartment is a diving compartment that holds up to 3 divers. The dive compartment is designed for lockout diving at depth. It's a 2.5 meter long aluminium cylinder, 1.5 meters in diameter, with hemispheres welded to each end. It's similar to what OceanGate's Titan looks like, except there is a hatch at the bottom for divers to climb out and into the ocean like a dive bell. The diver's compartment can be pressurized to the same pressure of the depth of the ocean, which allows the divers to leave through this hatch and conduct their dive. The 2 compartments are not designed for the crew to move between them. They're confined to either the pilot's compartment or the diver's lockout compartment. Immediately behind the diver's compartment is another sphere to hold diving gas. The gas in the cylinder is 86.5% helium and 13.5% oxygen. That cylinder can hold up to 130 bar of pressure, but I'm not sure if it's full at the time of the dive, and I don't know the capacity of the cylinder. The Sea Link's designer and builder was Edwin Albert Link, and he's on board the Sea Link's support vessel, the research ship Sea Diver. The Sea Diver has transported the Sea Link from Key West to the wreck of the Berry through the course of the morning. The crew members on the research ship will oversee the Sea Link's dive, and although it seems like there's no formalized command structure, Edwin Link is effectively in command of the dive operation. On board the Sea Link are the vessel's pilot, Archibald Menzies, and the scientist Robert Meek in the pilot's compartment. 2 passengers, Albert Stover and Edwin Clayton Link, are in the dive compartment. Edwin Clayton Link is the son of Edwin Albert Link, and he's known as Clayton. Although these 2 are in the dive compartment, they aren't planning to dive, and so, like the pilot's compartment, the dive compartment will be sealed and kept at the same pressure as the surface. It won't be pressurized to make a lockout dive. This is a routine dive, and according to the US Coast Guard investigation into the dive, it's the 130th dive the Sea Link will make. This Coast Guard report contains detailed information about the dive and is where I gathered most of the information for this account. Before the men depart, everyone gets ready. The Coast Guard report gives me the impression they're quite casual about safety. In the dive compartment, Stover and Clayton Link, who are there as research observers, are only dressed in shorts and t-shirts. It's really cold at the planned dive depth, and their choice of clothing doesn't take into account any delays or difficulty. Meek, who will be in the pilot's compartment, warns them, but they don't change their clothes. The pre-launch safety check of the Sea Link is completed by a training pilot instead of by Menzies. He discovers a potential problem. The training pilot finds that one of the 2 fans in the CO2 scrubber unit in the pilot's compartment is not working. The CO2 scrubber unit is there to absorb excess carbon dioxide and keep the air in the pilot's compartment safe to breathe. It'll work with only 1 fan, but if the second fan stops working, there's no backup. Instead of fixing the faulty fan, the training pilot casually mentions the problem to Menzies when he's getting into the vessel for the dive. The expedition proceeds without a backup fan. The vessel is hoisted into the sea, and at 0836, the Sea Link submerges below the waterline. It heads straight down, and 9 minutes later, the 4 men are 104 meters deep at the ocean floor. The pilot, Menzies, switches off the engine so he can estimate underwater current conditions by observing how much the Sea Link drifts in the water. He estimates drift is about 0.4 knots, and visibility is poor. This is fairly normal 100 meters deep in this area of Key West. Before he sets off, he trims the vessel to have a slightly negative buoyancy, meaning it'll sink slightly in the water. He does this to have better control over the craft and to stop it from floating upward and touching anything when they're nearer the sunken warship. Then he heads off towards the wreck of the Berry. At 0904, the crew takes sight of the Berry's anchor chain as they approach the ship. They're on the north side of the Berry. They have to ascend and pass over the ship to get to the other side where the fish trap's located. They pass over the Berry, and then Menzies drops the Sea Link back to the ocean floor just past the fish trap. He turns around and gets ready to approach the trap. The fish trap's positioned 4.5 meters away from the Berry. It's a good place to trap fish, but they need to be careful while they're so close to the shipwreck. He approaches the trap slowly and carefully by manipulating his side motors, rear motors, and both bow thrusters. They only have to travel 12 meters to reach the trap, which takes a few moments. As they're approaching, Menzies smells burning in the pilot's compartment and thinks there might be an electrical fault. They open the electrical covers to investigate, but don't find a problem. I imagine the problem distracts Menzies and probably makes him worry, but they can't find a fault. They continue on and arrive at the trap. All they need to do is pick it up and take it to the surface. It should be a simple procedure. On the front of the Sea Link is a 2.5 meter arm with a fork at the end. To pick up the trap, the fork is pushed onto the fish trap's rope, which is a line with 2 flotation balls that hold the line up. When the fork on the arm engages with the line, a mousing device locks the line in place like snapping a carabiner onto a rope. The flotation balls prevent the line from dropping out of the fork, and the pickup procedure is complete. Menzies tries to pick up the trap. He gets the retrieving line into the fork, but the mousing device fails and the line comes back out. He tries again. The arm is fixed to the Sea Link. It's not a robotic arm. In order to pick up the line, the pilot, Menzies, must maneuver the Sea Link into position. He backs up the Sea Link a short distance to try again. He gets the line into the fork, and again the mousing device fails. He backs up and tries again. Again the equipment fails. With 3 failed attempts, the crew decide it's not going to work and they abort the mission. I assume they plan to return to the surface, get the mousing device on the arm fixed, and then return to try again. While he's backing the Sea Link away from the trap, Menzies lets the vessel's bow drop and tilt slightly to port at around 5 to 10 degrees. The pivot point is in the center of the submersible. As Menzies dips the bow to port, the stern rises equally to starboard. Next, Menzies backs the Sea Link further away from the trap so they can get far enough away from the Berry to be able to head up to the surface. They've been on the ocean floor for an hour now, and the time is around 0945. As Menzies backs the Sea Link up, still tilted at a slight angle, it stops with a sudden jerk. The vessel is stuck on a cable from a flagpole on the sunken ship, but Menzies can't see that. It's caught by a hook on the starboard side of the Sea Link. It's the same type of hook they're using to try and catch the fish basket, but this one works. It's also caught underneath some other parts of the Sea Link that protrude on the starboard side. Menzies can't see because his vision of this area is obstructed by an air conditioning unit. The vision from the pilot's bubble is very good except for this one particular blind spot. He moves the vessel around to try and get them out, but they can't escape. They can move around 6 meters in any direction. or rotate through an arc of around 270 degrees, but that's it. They're stuck 110 meters deep with no obvious means of escape. The 4 men in the sea link begin to assess the situation they're in to work out what they can do. Communication between the pilot's compartment and the dive compartment goes through an intercom system. Menzies and Meek in the pilot's compartment have to switch between listen mode and talk mode when they're communicating with the 2 men in the dive compartment. Stover and Clayton Link just talk or listen over the intercom without having to flip a switch. The dive compartment line is constantly open, so the pilots can monitor the diver's compartments. They can also see each other through a porthole on the front of the dive compartment. Menzies tries some more maneuvers to free the sea link, but they think they'll just tangle themselves up more, and so they decide to stop. At 09:53, Menzies calls the sea diver using an underwater telephone to tell the dive command crew about the situation. After they finish talking to the men on the sea link, the command crew on the sea diver radio the Coast Guard to relay the situation and ask them to send Navy divers. From looking at the Coast Guard report, it seems that neither the Coast Guard nor the crew of the sea diver think the danger is immediate. A request for divers may sound fairly drastic, but perhaps no one is worried because they think they have plenty of time to make a rescue, either with divers or through a different means. They expect the life support system on the sea link to keep the men alive for long enough for them to plan and execute a rescue. They just have to find a way to rescue the vessel. They make the call to the Coast Guard at 10:05. The information is passed up through the Coast Guard's chain of command and on to the US Navy. The Navy decide to dispatch the submarine rescue ship USS Tringa from Key West to the scene. This ship has divers on board as well as other diving support equipment and is the right ship to perform this kind of rescue. The ship's departure is set for 1500. While the Coast Guard and the Navy start coordinating a rescue, there's a discussion between the dive command crew on the sea diver and the men in the sea link about the possibility of doing a lockout dive. The proposed plan is that one man exits the dive compartment into the sea to untangle the sea link from the steel cable. This is a simple plan and might sound like an obvious and easy solution. But unfortunately, things aren't simple in lockout diving. The dive compartment has 2 hatches, one that opens into the dive compartment and one that opens outwards into the sea. In order to open the hatch to make a lockout dive, they need to increase the pressure inside the compartment until it's equal to the water pressure. If the pressure isn't equalized, then the outer hatch won't open. They have compressed gas in the gas supply cylinder. They could use that gas to equalize the chamber's pressure, but that's a gamble. The increase in pressure will create an increase in the oxygen partial pressure in the dive compartment. At their depth of 110 meters, the surrounding pressure is 12 atmospheres. The 13.5% oxygen will have a partial pressure of 1.62. The men would have to breathe oxygen at this elevated partial pressure in the dive compartment. Air we breathe above the waterline has 0.2 partial pressure of oxygen. The maximum level we can tolerate is 1.6 for a short period of time. Dr. Youngblood, an expert on diving physiology who's on board the support vessel Sea Diver, estimates that anything over 2 hours at that partial pressure could be fatal. He advises against the attempt. If the men make a dive but find they can't untangle the vessel and they have to wait in the dive compartment, the rescuers on the surface will only have 2 hours to get them out. Shortly after they decide not to try a lockout dive, at around 10:30, Menzies detects a CO2 buildup in the pilot's compartment. He informs the sea diver and then checks the CO2 scrubber. What he finds is that the one fan motor that was working has now stopped. The CO2 scrubber works by blowing air through a canister containing a substance called Waterline. Waterline absorbs CO2 and the fan simply moves the air through the Waterline to encourage it to absorb CO2. Without a fan, it won't work and CO2 levels will rise to toxic levels. Exposure to high levels of carbon dioxide can be fatal quite quickly, but Menzies has an idea. He takes off his shirt and empties the Waterline from the scrubber into his shirt. Then he holds his Waterline-filled shirt in front of the air conditioning fans in the pilot's compartment. It works. This system creates an artificial CO2 scrubber to replace the one they've lost. Without this improvised fix, levels of CO2 would rise to toxic and then deadly levels. If CO2 levels do rise, there's an emergency oxygen supply that can be breathed through an oxygen mask. The supply is limited though, and they don't want to end up relying on it. It sounds from the report like they only have a few hours of air in the pilot's compartment. But for now, things are okay. At 11:30, Menzies reports to the sea diver that the CO2 levels in the pilot's compartment are dropping. They swap Menzies' t-shirt for a spare canister of Waterline to create a more permanent solution. And Menzies saves the Waterline from the original canister for later in case they need it. Efforts on the surface start to ramp up. At around midday, a small boat from the sea diver tries to get a buoy line down to the sea link. The idea is that when the Navy divers arrive, they'll be able to use the line to descend directly to the stricken vessel. Otherwise, they'll have to position the tringa as accurately as they can and then lower the divers down, which is not an easy task in over 100 meters of water. There is a buoy line that marks the berry, but it doesn't descend to the sea link. They know the approximate position of the berry and they know the sea link's on the south side of it, but getting an accurate fix is hard. And they need an accurate fix. The divers from the tringa will use surface supplied gas. That means they have a long hose that descends with them. If they descend in the wrong location, they'll have to drag 100 meters of hose through the water. Or worse, if they land on the berry, they could snag their own supply lines on the ship. The sea diver's boat tries to get a line down, but the line that marks the berry is in the way. While this is underway, Navy commanders in Key West called the US Navy Submarine Development Group in San Diego, California to ask for help. They prepare a roving diving bell with support personnel and equipment to be delivered by air to Key West. The diving bell offers an alternative if divers on the tringa can't manage to rescue the vessel. Just before the diving bell leaves California, the USS Tringa arrives on the scene. Dr. Youngblood and the support crew on board the dive support vessel Sea Diver calculate how long the CO2 scrubbers in the Sea Link will last. They need to last as long as it takes for the Sea Link to be rescued. Based on an assumption that the temperatures in the vessel will remain at 21 degrees Celsius, they calculate that the pilot's compartment will have 42 hours and the dive compartment will have 61 hours. So, while the situation is urgent, at least they have plenty of time. It's now 16:15 and the Sea Link has been stuck on the seabed for 6.5 hours. Since the tringa arrived, it's been trying to accurately position itself over the Sea Link. They've tried to determine the exact location of the submersible by lowering lights into the water for Menzies to see. And Menzies blinks the Sea Link's lights for the tringa to see. They do manage to sight each other, but according to the Coast Guard report, they can't get an exact location. So they have to estimate as accurately as they can. The tringa begins maneuvering to set a 4-point mooring over the Sea Link's position. To send divers down, they need the stability of a 4-point mooring, but it takes time to set. By 2015, the tringa completes its mooring within 10 meters of the buoy line marking the berry. The hope is that the positioning is accurate and the divers will descend close enough to the Sea Link. While the tringa's divers prepare to go in the water, the CO2 scrubbers in the Sea Link's dive compartment start to malfunction. Temperatures have dropped inside the compartment. At lower temperatures, the ability for the chemical Waterline to absorb CO2 diminishes significantly. The temperature in the aluminium dive compartment is dropping quicker than the pilot's acrylic compartment. According to the Coast Guard report, temperatures in the dive compartment could be as low as 7 degrees Celsius. The men, dressed in shorts and t-shirts, are suffering in the cold, and the Waterline is quickly losing effectiveness. At the surface, they've calculated the air supply based on temperatures of 21 degrees Celsius. When the Waterline stops working, carbon dioxide in the Sea Link will become toxic. They'll have to switch to using the mask-supplied oxygen, which comes from a high-pressure cylinder. Although it isn't clear from the Coast Guard reports exactly how much oxygen there is, this is a limited supply. At around 2200, Stover and Clayton report that the Waterline in their CO2 scrubber has lost all effectiveness, and at 2225 they switch to using the oxygen masks. According to the Coast Guard report, as the CO2 levels in the dive compartment rise, the internal pressure in the dive compartment also rises to around 2 atmospheres. The pressure continues to rise until it reaches 3 atmospheres by 2245. The men are breathing oxygen from a pressurized cylinder. As the gas moves from a high-pressure cylinder into the dive compartment, the pressure in the dive compartment increases. 2 hard hat divers from the Tringa start their 110-meter descent to try and locate the men. From a depth of 96 meters, they spot the sea link. They can see it underwater from the side of the berry, and it's snagged on something. They're close enough to see the vessel, but they can't get to it. Their way is obstructed by the wreck of the berry. What looks like a radar dish is in their way, along with other obstructions. They can't get through the obstructions with their surface supply gas lines, so they can't get to the men to free them. Going any further would mean taking a big risk of entangling themselves. They abort the dive and return to the surface. As the Tringa's divers ascend slowly, doing decompression stops, personnel on board the Sea Diver support vessel revisit the possibility of a lockout dive. It's a fleeting discussion. Stover and Clayton in the diver's compartment don't want to risk leaving the sea link. The crew on the Sea Diver accepts their decision. At 2311, the oxygen supply is exhausted in the diver's compartment. Stover and Clayton switch to the helium and oxygen gas supply in the rear of the vessel. While the Tringa's divers return slowly to the surface, the ship tries to reposition itself for clear access on the next dive. Down in the sea link, the pressure in the dive compartment continues to rise. It reaches 10 atmospheres at midnight, and at 0015 the hatch pops open as it reaches the equivalent of the 12 atmospheres in the surrounding water pressure. Again, the team discussed doing a lockout dive. The Coast Guard report doesn't give a great deal of information about this conversation, but I imagine the command crew of the Sea Diver are becoming quite desperate now. Maybe they're trying to convince Stover and Clayton to make the dive. Maybe Edwin Link thinks it's the only hope for his son and Stover. They're on a dwindling supply of oxygen-rich gas, and once that runs out, the CO2 levels will rise. They raise the idea of a lockout dive with the 2 men in the diver's compartment, but according to the Coast Guard report, they say they're too cold to try. Again, the command crew on the Sea Diver accept the decision of the 2 men in the sea link and hope that a diving rescue from the Tringa will work. At 0030, communications go quiet with the men in the dive compartment, while Menzies tries to help the Tringa locate itself directly above him. He's looking at lights suspended beneath the Tringa to aid their positioning. It's not clear what's known about the men in the dive compartment. There's no contact with them after 0030, but we don't know if that's because they're unconscious or if the comms stop working. It's quite likely that the 2 men slowly become incapacitated and aren't able to respond to any attempt to reach them. We don't know at what point their oxygen levels drop to the point that they lose consciousness. It seems that they simply just go quiet. At 0112 on the 18th, Menzies reports to the surface that Stover and Clayton Link are both suffering convulsions. The 2 men are now suffering from carbon dioxide poisoning. There's a slim chance they can still be saved if the divers from Tringa get to them quickly. Edwin Link hears the news that his son is in the process of dying at the bottom of the sea, 100 meters below him. Attention now shifts to the 2 men in the pilot's compartment. Their acrylic bubble is better insulated than the diver's compartment, but it's getting colder. Eventually, the Waterline in their CO2 scrubber will stop working. Then, Menzies and Meek will have to switch to their emergency oxygen supply as well. 13 minutes pass, and at 0135, the divers from the Tringa start their second dive down to the sea link. It takes them 8 minutes to reach the bottom. They report to Menzies that they've completed their descent. Menzies scans the ocean floor for the divers' lights. You have to imagine a sense of panic rising for Menzies and Meek in the pilot's compartment. In the compartment behind them, their colleagues are convulsing. I'm sure they're concerned not only for Stoker and Clayton, but also starting to think about the same fate for themselves. Menzies must be hoping the divers have landed close enough to rescue the Sea Link. They might even save the men in the dive compartment if they get them to the surface quickly. He looks, but he can't see their lights. Once again, the divers have landed on the wrong side of the berry, and they have to abort the dive. Sometime during the second dive, the roving dive bell arrives. It's been flown from California to Key West, loaded onto a support vessel, and sailed to the location. It's transferred to the Tringa at 02:45 on the 18th of June. Over the next few hours, the dive bell is readied and an attempt is made to dive to the Sea Link at 06:05. 2 divers are in the bell. They descend to 85 meters in the bell and then begin their dive using the bell as a staging point. 1 diver exits the bell. He's immediately pulled into a strong current. The current's so strong that he becomes fouled in his umbilical and can't descend any further. It takes him 15 minutes to untangle himself and return to the bell. They abort the attempt and bring the bell to the surface. The USS Amberjack arrives at the location. Rescuers then check the charts and discover the current is tidal with the next slack tide at around 1200. There's another delay of a few hours. At 09:51, they send the bell back down with lights attached and no divers so they can establish the right location for their next dive. When they lower the bell, the current pushes it into the shipwreck and gets stuck. They can't lower or raise it any further. The rescue team regroup and formulate a different plan. At 12:40, a submersible vessel called the Perry Submarine, which arrived on board the USS Amberjack, is sent down to locate the Sea Link. It has to return to the surface an hour and a half later because its sonar isn't working. It doesn't locate the Sea Link, which has now been trapped for 30 hours. The 2 men in the diver's compartment, Stover and Clayton Link, have now been unresponsive for over 13 hours. Just before the Perry Submarine surfaces, the salvage vessel motor vessel AB Wood 2 arrives on the scene. Just as the Wood arrives, the barrelime in the pilot's compartment is exhausted, and the 2 men have to switch to using their oxygen masks. They only have a few hours of oxygen left. I'm sure Menzies and Meek are hoping they don't have to face the same fate as Stover and Clayton Link. Hopes are now turned towards the newly arrived ship, the Wood. The ship has an underwater ROV with a camera that can be maneuvered by personnel on the surface. If they can get it down to the Sea Link, they might be able to work out what to do. The Wood launches its ROV about an hour and a half after it arrives, just after 1500. They manage to lower the camera on the ROV, and for the first time they get a clear picture of the predicament the Sea Link is in. The crew on the Wood can see the cable that snagged the Sea Link on its starboard side. After Dr. Youngblood and the crew on the Sea Diver miscalculated how quickly the barrelime would deteriorate based on warmer temperatures, he's now concerned that the men in the pilot's compartment are down to their last hours of breathable air. The clock is ticking, so the rescue party formulates a risky plan. They bring the ROV back up to the surface, attach a 4-pronged grapnel to it with a 3-meter length of steel cable, and lower it back down. With the camera's guidance, they manage to attach 1 hook of the grapnel onto the Sea Link. Menzies sees the hook go in and reports this back to the surface at 16:41. At the surface, the Wood starts to winch in the ROV, which now has the Sea Link attached at the end of the cable. At first, the submersible tilts at a steep angle, held down at the rear starboard corner by the snap hook that's snagged on the shipwreck. Then the snap hook that's holding the cable breaks open and the cable holding them on the ocean floor comes loose. The Sea Link rises up to the surface as the line is reeled in. Just 12 minutes later, at 16:53, the Sea Link is finally lifted into fresh air. Menzies and Meek will survive. Much like the diver's compartment, when Menzies and Meek started breathing from the oxygen tank, the pressure inside the pilot's chamber started to rise. After they surfaced, they're transferred to the Tringa's recompression chamber. Their decompression begins at 17:15. Next, rescuers turn their attention to Stover and Clayton Link. There's still a slim chance they may be unconscious but alive. They tow the Sea Link over to the sea diver and hoist it on board. They can see Stover and Clayton Link through the dive compartment viewports. There are no signs of life, and it's been a long time since there was any response from the men, but they'll try to revive them anyway. The sea diver goes alongside the Tringa and takes a pressurized air hose from the ship. They use this to vent the dive compartment while it's still pressurized. They spray hot water over the sides of the aluminium compartment to try and raise the internal temperature. The hope is that if the men are still alive, the air and warmth will revive them. The two men are left inside the dive compartment as it fills with breathable air and warms up. At 18:45, the ROV and camera are used to recover the foul diving bell. Menzies and Meek complete their decompression at 19:15 and are declared medically fit. At 2300, the diving bell is freed and lifted onto the Tringa. Everything is stowed and everyone is safe except for Stover and Clayton Link in the Sea Link's dive compartments. 14 hours pass with no signs of life from the two men. Doctors on board declare both men dead. The ventilation and hot water operation is stopped and they begin to depressurize the compartment to retrieve their bodies. An autopsy shows that both men died from carbon dioxide poisoning.